So functional groups are how these different atoms and molecules, how they're put together makes this molecule function in a specific manner. So in the beginning, we had a molecular formula C2H6O. And we looked at two ways we could put that together, where we had a carbon, oxygen, carbon, and then surrounded with hydrogens on both of those carbons. And we also had a carbon bonded to a carbon, and then an oxygen, and then a hydrogen. And we looked at one was an alcohol, one was an ether. Those are actual functional groups. And that has to do with the location of the atoms and how they're bonded. So in this one here, when we have a carbon, oxygen, carbon, it makes, because we have these bonds in this certain order between specific elements, oxygen, carbon, it makes it function a certain way, behave differently. This would be an ether, which is a functional group, versus down here we have an oxygen, hydrogen attached to a carbon, makes this an alcohol. They behave differently. They function in a certain way. So this is how we can actually classify organic compounds. So we can kind of make a flow chart here that we have organic versus inorganic, and then in organic we can classify them in different ways depending on how atoms are put together into functional groups. So in chapter 10, the ones that we're going to learn about, this chart shows you a whole bunch of functional groups. We're not going to cover all of those. In chapter 10, we're going to learn about alcohols. We'll learn about ethers, I mentioned, but that will be later on. We're going to learn about aldehydes, ketones, carboxylic acids, esters, and amines. So those are the functional groups that we'll be covering in chapter 10. We'll be learning about other functional groups in some of the following chapters, but definitely not everything on this chart. So just to kind of point out, the elements in blue are what make it function a certain way. So in the alcohol, we have in blue, we have the OH. When the oxygen's bonded to a hydrogen, and then it's attached to a carbon with single bonds, makes it an alcohol. The aldehyde, we'll see here in blue, we have a carbon with a double bond to an oxygen and a hydrogen, makes it an aldehyde. The one down here, we have carbon with a double bond to oxygen with carbons on both sides, a ketone. So we'll go through each one of these separately. Carboxylic acid, and then we have esters. Notice they all have carbon with double bond to oxygen, but something different on each side of those carbon. Amines are really easy to spot because that's the one that has nitrogen in it. So again, how these atoms are put together means they would function a certain way. So for this chapter, we can look at, we have organic chemistry as a general area, then we have alcohols, and then we have aldehydes. I don't have enough lines here to fit, but you could imagine if I continued on, carboxylic acids, etc. And then we're going to see that we can classify even further. So alcohols we can classify into what we call primary, secondary, and tertiary. So that's what we'll be looking at next. So alcohols are a functional group within organic chemistry. And what makes something an alcohol is when we have what we call a hydroxyl group. That means we have an oxygen with a single bond to a hydrogen. This oxygen is attached to a carbon. That carbon has all single bonds around it. This is what makes something an alcohol. So within alcohols, there's a specific one we have here is ethanol, which is again drinking alcohol, but there's all different types of alcohols. Chapter 14 is a whole chapter on alcohols that we would get more specifically into. So for this chapter, we're just learning how do you spot an alcohol. So you'll need to remember how to find that functional group. So if I give you a compound like this, for example, I'm going to circle the functional group. I've got a carbon attached to an oxygen and a hydrogen, and it has all single bonds attached to that carbon. That's what makes this an alcohol. Okay, this specific one where we have two carbons is called ethanol. At this point, we don't have to worry about learning how to name them. We'll get to that later. We can also do, just a little review. The molecular formula for here is C2H6O. The condensed structural formula, again, we have a CH3 at the end. We have a CH2, and then we show our OH. So this is still showing us the functional group here when it's written in this format, versus the molecular formula doesn't tell me anything about what kind of compound I have. So alcohols can be classified further. So as I said, we have kind of organic compounds as our overbranching topic at the top. Then we have alcohols. Within alcohols, we're going to have what we call primary, secondary, and tertiary, symbolized by 1, 2, and 3. So we're going to learn the difference between a primary, secondary, and tertiary. So primary is the first one we're going to start with. So what a primary alcohol is when I have a carbon, okay, that's attached to my hydroxyl group, that makes it the alcohol. I'm looking at the carbon that's attached to the OH. How many other carbons is it directly bonded to? So in this example, this carbon is attached to one other carbon and 2 hydrogens. So it's attached only to one other carbon. That makes it a primary alcohol when it's bonded to only one other carbon. Okay, a secondary alcohol is when I have a carbon, it's bonded to that hydroxyl group. It's bonded directly to 2 other carbons. So let's look at our example here. I'm going to highlight the carbon in red that's attached to my hydroxyl. I'm going to look at how many other carbons is that bonded to. And it's directly, not the total number of carbons in the molecule. So the carbon in red is attached to 2 other carbons and a hydrogen. So the number of carbons it's attached to is 2. That makes it a secondary alcohol. This one I was also asking for us to draw the condensed structural. So let's go ahead and do that. We have a CH3 at the end. We have a CH2. And then we have a CHOH. And then we have the CH3 hanging down here. So I call that sort of a branch that would be coming off my tree trunk, if you want to call it that. So this one we want to leave just hanging down like this, or it could be pointed upwards. Show me that there's something that's coming off of that CH3. So a tertiary alcohol is when we have the carbon that's attached to my hydroxyl group is bonded to 3 other carbons. So in this example, again, I look at the carbon attached to the OH, and I look at the other carbons that are directly bonded to that are 3 carbons. So that makes it a tertiary alcohol. Condensed structural formula for this compound is we could write CH3 at the end, and then we have not a lot of condensing. I already wrote this in a sort of a combined structure of condensed and structural formula. Not a very good way to draw my molecule, but I have CH3 at the top and CH3 at the bottom, so I kind of have 2 branches coming off my center carbon here for my condensed structural formula. Is this compound a primary, secondary, or tertiary alcohol? So again, first thing is you find the carbon that's attached to my hydroxyl group. And then I look at that carbon and I determine how many other carbons is it directly bonded to. Again, not the total carbons in my molecule, but what it's directly bonded to. So this carbon is attached to 2 other carbons, a hydrogen and an oxygen. We're only looking at the carbon. So it's attached to 2 other carbons, therefore this must be a secondary alcohol. So our next functional group we're going to talk about is amines. So again, we can say we have organic compounds, things that contain carbon. Then we have alcohols, and then amines. That would be branches coming off the top of our flow chart. Alcohols we can classify as primary, secondary, and tertiary. Amines, we're going to be able to do the same thing as well. We can classify amines as primary, secondary, and tertiary. So it's a little bit different that we'll be covering. But first, let's talk about an amine. So an amine is the easiest to spot of the functional groups. Amines contain nitrogen. So anytime I give you a compound and I ask you determine the functional groups in it, if you see nitrogen, you're going to have an amine. There's other types of functional groups, but that's the only one we're going to learn is amines. So it's when I have nitrogens that bonded to either 1, 2, or 3 carbons is going to be telling me if I have primary, secondary, or tertiary that we'll get to. So in my model down here, the blue ball represents my nitrogen. The white balls are my hydrogens, and then the black ones are carbons. So this one is showing me here I have a nitrogen that's attached to 1 carbon and 2 hydrogens. So it's an amine because we have a nitrogen. So again, we can classify our amines as primary, secondary, or tertiary. So we're going to start with primary first. And what a primary amine is when we have a nitrogen bonded directly to one other carbon and 2 hydrogens. So we can really just try to remember the number of carbons. So primary means 1, so if it's attached to one other carbon. So if I look at my nitrogen and I see how many carbons it's bonded to, one other carbon, that's what makes it a primary amine. A secondary amine is when we have a nitrogen bonded to 2 other carbons and a hydrogen. So we look at our nitrogen, we're looking again what it's directly bonded to, not the total number of carbons. So I have 1 carbon here, another carbon there. So it's directly bonded to 1 hydrogen, 2 carbons. That makes it a secondary amine. A tertiary amine is where I have nitrogen bonded to 3 carbons. So again, I look at my nitrogen and I'm looking at what it's directly bonded to. 1 carbon here, another carbon here, and this may not be as easy to see, but this nitrogen is bonded directly to this carbon. So let me go ahead and draw out the structural so you can see that better. Because on the one at the top and the bottom, it's pretty straightforward to see. But sometimes when you're doing condensed structural formulas, it's hard to determine what it's actually bonded to. So when I draw out the full structural formula, I can see this bond between carbon and nitrogen here. And I can see all 3 of them, that it's attached to 3. So that's something when people first get started and they love doing condensed structural because it's a little bit, it's a shortcut, saves you time. But make sure you can imagine here that my carbon is really, the 3 hydrogens are sort of found outwards and it's attached directly to the nitrogen. Because sometimes people might make a mistake and call this a secondary carbon, but this nitrogen is bonded directly to that carbon. So we have a tertiary amine. Is this compound a primary, secondary, or tertiary amine? So again, we're going to start by looking where our nitrogen is. That tells me I have an amine. I'm going to look at how many carbons are attached to that nitrogen. In this case, it's directly bonded only to one other carbon. So therefore, it must be a primary amine. Our next functional group we're going to look at is a carbonyl group. A carbonyl group is when I have a carbon with a double bond to an oxygen. And again, we have single bonds on both sides of the carbons. It means something else is attached here. And that's going to make it more specific to what type of functional group it is that contains a carbonyl group. So we're going to be looking at 4 more functional groups called aldehydes, ketones, carboxylic acids, and carboxylic esters. All of those functional groups contain a carbonyl group. So for me, when I'm asking for functional groups in a compound, I want you to be more specific and not say just carbonyl. I want more specifically whether it's the aldehyde, ketone, carboxylic acid, or carboxylic ester. So make sure if I ask for functional groups that you list one of these if you see a carbonyl. So we're going to look at those next 4 and see what's the difference between them. What's common? Common to all of them is the carbonyl group, but there's a slight difference in each one of those. So the first functional group we're going to look at is an aldehyde. So an aldehyde contains, again, the carbonyl group. Okay, and in this case, my carbonyl group is bonded to a hydrogen. So let's look at the picture on the left first. I'm going to go ahead and I'm going to circle the functional group in red. Okay, so what we have here is carbon with the double bond to the oxygen. That's my carbonyl, and in this case, this carbon is attached to a hydrogen. That's what makes it the aldehyde, versus we're going to see what's the difference with the ketones, the carboxylic acid, and esters in our next examples. So one thing I might recommend is making some flashcards, and on one side of the flashcard, write aldehyde. The other side is the part I've circled in red. That's the actual portion of the molecule that makes it an aldehyde. So you need to remember the order of the carbon, double bond to oxygen with a hydrogen attached to it. That's an aldehyde. Looking at my model of what the compound would actually look like is the black balls represent carbons here, and the red ball represents oxygen. So here we have a double bond between the carbon and oxygen. The white balls are all hydrogens, and the rest of them are single bonds. But again, with the actual model, you can see it's the bond angles are, it's not straight across 90-degree bonds. There's actually different angles between it, kind of more of that zigzag. So going back, if I wanted to do a line angle drawing of this, I could do something like that. And this would represent, again, each carbon would represent the ends and the point. And if there's hydrogens, you don't have to show them. But if you had another element attached, like in this case we have an oxygen, I would need to show that by drawing a double bond in oxygen. And then again, everything that's not drawn is implied. So my line angle drawing would look something like this. Then I'd have my double bond oxygen coming off at the end. So this is our aldehyde. Know the functional group. Carbon double bond to oxygen with a hydrogen attached, single bond to that one carbon. Okay, a ketone also contains that carbonyl group. The difference between the ketone and the aldehyde is the ketone has two other carbons attached to the carbon of the carbonyl group. So I'm talking right here. Here's my carbon with the carbonyl group. And on each side, I have a carbon attached where the aldehyde had a hydrogen on one of those sides. So I'm going to circle my functional group in this compound. And again, might recommend making a flashcard, ketone on one side, what the functional group looks like on the other. Looking at my model on the right, I can go ahead and label carbon in the center, that black ball. This is an oxygen with the double bond, and then a carbon down here. And then a single bond to another carbon. Again, all of these red balls are the hydrogens. So if I wanted a line angle drawing of this one, I've got a total of 3 carbons. So I have this sort of zigzag with the double bond at the top. Carboxylic acids are when we have a functional group where we have a carbonyl, and that carbonyl is attached to a hydroxyl. So we've got the carbonyl, let me just write this down here, attached to a hydroxyl. This is what we call a carboxyl group, and that's what's in a carboxylic acid. And then again, we have something attached on the other side of that carbon, and it could be many other carbons or something else. So let me go ahead and circle the functional group here, carbonyl, and then that's attached to the carbon that's a part of the carbonyl is attached to a hydroxyl. So that's my functional group and a carboxylic acid. And then again, just looking at the model on the right, drawing in my oxygens, my hydrogens, and then that would be my carbons here of what it would actually look like. Okay, carboxylic esters also contain that carbonyl group. The difference with this one is in my carbonyl group, the carbon of the carbonyl group is attached to an oxygen that's attached to another carbon. So I have an oxygen bonded to another carbon. So let me go ahead and circle the functional group in red here. Looks like that. So we've got the carbonyl attached to the carbon of the carbonyl attached to another oxygen attached to a carbon. That makes what we call a carboxylic ester. So you need to remember the names of these different functional groups. And again, I can go ahead and label our one down here, our oxygens, hydrogens, it's supposed to say oxygen. And then we have a carbon, 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 carbon. Okay, so you need to know the different functional groups. So let me do sort of an overview of what we've covered in our organic. See if I have enough space here. So in this chapter, we did alcohols, amines, okay, and then we had aldehydes, ketones. I'm going to say C acids for carboxylic acids, and then C esters. This is a really bad looking flow chart. Okay, alcohols we could classify as primary, secondary, tertiary. Amines we did as primary, secondary, and tertiary. Now aldehydes, ketones, carboxylic acids, and carboxylic esters, we do not classify those as primary, secondary, tertiary. The thing that's in common with these four down here is they all have that carbonyl group attached somewhere in that molecule. A little bit different on what's attached to that carbon with the bonds, whether it's another oxygen on one side, a hydrogen. It makes it slightly different. So you want to make sure you know these different functional groups. So we're going to do a little bit of practice with that. So I'm going to give you a compound and ask you to identify functional groups. So in an organic compound, it can have more than one functional group in it. So in this compound, we want to identify the functional groups. So we see we have carbonyl. Well, carbonyl, I don't want you just to specify carbonyl, I want more specific. So in this one at the end, we have a carbonyl that's attached to a hydrogen, where the carbon is attached to a hydrogen. This makes it an aldehyde. Your aldehydes will always be at the end of your compound, whether it's on the right-hand side or the left-hand side, doesn't matter. Again, these are three-dimensional molecules. I could flip this around, but be able to recognize this is an aldehyde here. We have another carbonyl in the center here. We look at what's attached to that carbon. So it's directly attached. We can see easily on the right another carbon. What's attached on the left is, again, if we imagine if this was drawn all the way out, it's attached directly to this other carbon, not the hydrogen. So if we have a carbonyl, the carbon of the carbonyl attached to two other carbons, that makes this a ketone. So this compound has two functional groups. So I may ask you a question where I may say circle and then name or identify the functional group. So I want you to identify the functional groups in this compound. Again, we have more than one functional group. So we can see on the right-hand side, we have that carbonyl, and the carbon, we're going to look at the carbon and the carbonyl, and what else is attached to is a hydroxyl group. So I'm circling the functional group, and then I want to go ahead and name it. So a carbonyl attached with a hydroxyl gives me a carboxylic acid. The other one that should be a little easy to spot is whenever I have a nitrogen, that tells me I have an amine. So then with the amines and the alcohols, I'd want you to classify if it's primary, secondary, or tertiary. So I'm going to circle what the nitrogen is attached to. And I'm looking at the nitrogen, how many carbons is it directly bonded to? So this is directly bonded to two hydrogens and one carbon. So one carbon means this is going to be a primary amine. So my two functional groups in this compound, we have a primary amine and a carboxylic acid. Identify the functional groups in the compound below. So on the right, I have a carbonyl. I'm looking what's attached to that carbonyl is I have a carbon attached to an oxygen attached to another carbon. So this functional group here is my carboxylic ester. And then I'm looking what else I have here. Here I have a carbon that's attached to a hydroxyl. This makes it an alcohol. Okay, and then I want to determine with the alcohols if it's primary, secondary, or tertiary. So I'm going to look at how many carbons the one that's attached to the hydroxyl is directly attached to. So I'm circling all of that. So this carbon here is attached to two other carbons. That makes this a secondary alcohol. So those are my two functional groups in this compound. I have a secondary alcohol and a carboxylic ester. So on this slide, I have a number of different amino acids. Amino acids are used to build proteins in your body. I want to start by drawing in, because this is has a key down here at the bottom. So the black balls represent my carbons. So let me go ahead and draw in. This is carbon. I don't know if we can see that very well. So any of those kind of gray balls represent my carbons here. I'm not going to draw them all in on that compound, the tyrosine on the right. The white balls here represent hydrogen. So I'll go ahead and draw some of those in. See if that can help us identify functional groups. So we'll just draw some of those in. Okay, so let's look at the first one. We have alanine up on the left-hand corner. So again, this is a carbon here. It's attached with a double bond to an oxygen, and then it's attached to an OH, which is our hydroxyl. So when we have a carbon with a double bond to an oxygen and an OH on the right or on the left attached to it, that makes a carboxylic acid. The other one that's easy to spot is we have a nitrogen. So nitrogen, again, tells me I have an amine. So we know we have an amine in here. And then we want to determine if it's primary, secondary, or tertiary amine. So we're looking at how many carbons are directly bonded to that nitrogen. So it's directly bonded to two hydrogens and one carbon. Therefore, it's going to be a primary amine. Now let's look at glycine, the one below. So this one basically has the same functional groups. We have carbon, double bond to oxygen, your carbonyl attached to hydroxyl. So again, we have that carboxy acid. And then we have nitrogen with a single bond to carbon, giving me the primary amine. So these are different with what's attached to the carbon between the nitrogen and the other carbon. Let's go to the one in the center. Again, we see some similarities here. We have a primary amine, and we also have that same carboxylic acid. Now there's a functional group that is down here at the bottom. This is called a thiol. And we're not going to learn about this in chapter, but that's something that will be coming up. And again, it's easy to spot because it has a sulfur, but that's in a later chapter, so don't worry about that yet. This one at the end, we also have the carboxy acid. And we have the primary amine. Another functional group we'll be learning about, again in a later chapter, it's chapter 13, but this part here is called aromatic, where we have 6 carbons in a ring, and it's got this circle in the middle that represents an aromatic compound, and then it has this OH attached at the end down here. When we have an OH attached to this aromatic ring, it's called a phenol. But again, we don't have to learn that one yet. That's going to come later. So for this chapter, know the primary amine and carboxylic acids on this slide. In this slide, we have a model that I'd like you to try to pick out functional groups. Now I'm going to go ahead and label some of our elements so we know what they are. So our blue balls represent nitrogen. So that gives us a hint. We have a couple of amines here. The red balls represent oxygen. And this is actually a double bond. And then in this case, all the green balls are hydrogen. I don't know if I'm going to draw all those in. And then the black balls are our carbons. So I'm going to draw some in that it's going to help us identify some functional groups. So let's go ahead and start on the left-hand side of the molecule. We have a nitrogen. So that tells us we have an amine. And I'm looking at this nitrogen. How many carbons it's attached to is just one carbon, 2 hydrogens. So that makes it a primary amine. Let's go ahead and jump to the right-hand side of our molecule where we have this other nitrogen. Now this nitrogen here, again, we have an amine. Again, we can have multiple functional groups in an organic compound. This nitrogen is attached to 3 other carbons directly. 3 other carbons means it's going to be a primary amine. Now we also have in the center where our red balls, which are oxygens, we have a carbon that's attached with a double bond to an oxygen, so we have a carbonyl. So we're going to see that carbon here is attached to an oxygen and then another carbon. So let me circle that portion here. That makes this a carboxylic ester. Okay, so those are the 3 functional groups that we have learned about in this chapter in this compound. So here's 2 more compounds that I'd like you to circle and name the functional groups. So the first one we see, we've got this carbonyl. We're going to look at what's attached to the carbon in our carbonyl, and it's directly bonded to 2 other carbons. This makes this a ketone. And I don't see anything else in that compound, so it's got one functional group. The compound at the bottom, we look at the carbon. This is attached to an OH or a hydroxyl group. That tells us we have an alcohol. And again, to be an alcohol, the carbon that's attached to the hydroxyl has to have all single bonds, which this one does. And we look at how many carbons is that carbon that's attached to the hydroxyl directly bonded to, and it's 1. So that makes this a primary alcohol. So in this one, same thing. I want you to circle and name the functional groups that you see. And I would like to go ahead and draw in our carbons because this one has some line angle drawing with it. So again, every point represents a carbon. So in this compound, let's start at the top of it. So we have let me use a new color. We have a carbon with a double bond to an oxygen. Tells us we have the carbonyl here. We're going to look at what else is attached to this carbon attached to the double bond O. So if we go to the right, we've got the hydroxyl. So we have a carbon attached to an oxygen, carbonyl, plus the OH, the hydroxyl. That gives us a carboxylic acid. Okay, let's go to the right here. So we have an OH attached to a carbon. Now you might think that's an alcohol. This is not an alcohol. The reason it's not an alcohol, because if we look at this carbon here, there is a double bond. To be an alcohol, the carbon must have 4 single bonds. So this is actually not an alcohol. It's another functional group that we'll be learning about in a later chapter. When you have an OH attached to this aromatic ring, it's called a phenol. So don't worry about that yet. That's coming later. So then the other one we have down on the left-hand side, we see our nitrogen, which tells us we have an amine. And then we look at that nitrogen, how many carbons it's directly bonded to, which in this case it's bonded to 1 carbon, 2 hydrogens. So 1 carbon means it's a primary amine. So the functional groups in this chapter you need to know are primary amine and the carboxylic acid.